Hi, this is going to be part 2 of exponent properties. The last video we went over why the rules are what they are, and they're not necessarily rules, they're just shortcuts. And they're called the exponent properties. So exponential properties is the official word. So we're gonna just go over a few more examples and we're just gonna keep using these examples, and I'm gonna show the triples method. Or sorry, not the triples method. I'm going to be showing the expanded notation and the triples method just to really ingrain what the different meanings are. Okay, so let's go over example number 1. M to the negative third times m to the fifth power. So the first thing to check is, yep, the bases are the same, so we can mess with the exponents. Well, m to the negative third is kind of a weird one, isn't it? Because it's negative, we know eventually it's going to turn into a fraction. And the fractions make things smaller, generally speaking. So here's how you write this in exponential form. First off, don't worry about that one first. Let's write the 5m's. Let's expand those out. M times m times m times m times m divided by. Ooh, didn't mean to do that. Divided by. Now, I'm dividing because m to the negative third, well, is going to turn into 1 over m to the third. 1 over m to the third. I know that's going to happen because it's a negative exponent. What that basically means it's going to end up in the denominator, and if we multiply straight across, they're just going to go in the bottom. So I'm going to put, so when I see negative 3 on like a multiplication problem like this, I'm going to put the 3m's, m, and m in the denominator. Now it's the same old thing as ever. M divided by m is equal to 1, because remember, I can divide or multiply in any order I want. M divided by m is 1. M divided by m is 1. So 3 pairs canceled out. That only leaves us, I'm going to clean it up, with 2m's, m times m, which is equal to m squared. And so that's how this works with expanded notation, when the bases are multiplying. So the question is, can we use our properties as before? Well, let's check it out. Our property when the bases are the same, if you look in your notes from last time, which I highly, highly advise, I can add the exponents together when the two bases are multiplying, when the two powers are multiplying together. So I can write one base, that doesn't change, it's m, to the negative 3 plus 5. Well, negative 3 plus 5 is 2. So this is m squared. And then we're done. You have to show this step right here, or I'm not going to think you understood what you were doing and you were just guessing. But that's it. That's us using the properties. Look at the amount of work we had to do over here, and think about what we did with the properties over there. So are the properties something that you have to know for a test? No, if you can figure this out, go for it. But if you're doing 60 problems on tests and you only have so much time, it might be better to know the properties. All right, let's go on to another example. What if I have 4 to the 10th power divided by 4 to the 7th? Again, I'm going to just rewrite this. This is 4, 4, 4, all multiplied together. 4, 5, 6, 7, 8, 9, 10. So I have 10 4s on top, 7 4s on the bottom. This is good practice for us to do still, because I'm not quite confident that you understand the properties exactly. This shows you really understand the properties. It shows you can go from expanded notation and shrink and do this and that. It really shows you understand it if you're able to do this. 4 divided by 4 is 1. 4 divided by 4 is 1. 1, 1, 1, 1, 1. What do we have left? Well, it looks like we have 3 4s on top. Awesome. Well, 4 times 4 times 4 is equal to 4 to the third power. Again, what property did I just show? Well, 4 to the 10th divided by 4 to the 7. Are the bases the same? There's a base of 4, there's a base of 4. So I can use my exponent properties to say 4 to the 10. The top number goes on the first minus the bottom exponent. You've got to put the top exponent first, bottom exponent second. Okay? Is equal to 4 to the third power. Done. Again, either way is fine by me. Do what you want. All right. Y to the fourth, then raised to the sixth power. So, first off, and there's a few ways we can do this one. Let's go with this one. I'm going to write y to the fourth 6 times 3, 4, 5, 6. And then I'm going to write that one. This is going to get tiny. Here we go. Each one 4 times. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. So, how many do I got? 24. Okay. Why did 24 power? God, these one. I honestly say this. Doing the power to a power is the worst one to expand out. Look how ridiculous that looks. Oh, God, it makes me feel so bad. Yes, I want you to write it out. Y to the fourth raised to the sixth power. What are we really doing? Really, we're taking y 4 times 6. And I want to see that step. I want to see y to the 4 times 6. Well, 4 times 6 is 24. So y to the 24 power. Be careful how you're writing these. I'm noticing you guys are writing these numbers bigger and like so it look like y times 24. Be careful. Be very, very careful. So that's us using the properties. Good little practice. Let's do some. Let's kick it up a notch, as Emerald, the chef, would say. Let's go to a new level. So I'm just going to jump right in and say, let's use the properties. This is equal to 6 to the 8 plus negative 10. Right? I'm just adding the exponents together, just doing it. Well, 8 plus negative 10 is negative 2. So now we have 6 to the negative 2, which we can't leave like that. If you see a negative exponent, you have to make it positive. End of discussion. Well, a negative exponent means I'm going to take 6 and turn it into its reciprocal. So 1 over 6 to the second power. Period. We don't want to leave it like this. 6 squared. Don't write it like that. That's really sloppy, and you want to do it like you want to do the other one. So do that one. Okay. Go ahead. Let's look at example B. The bases are the same. If the powers are dividing, the exponents are going to subtract. So we're going to have n to the 8 minus 13. Okay? 8 minus 13 is negative 5. Again, my throat. Again, we can't leave the exponent negative, so we have to change it positive. We take n and turn it into its reciprocal. Even though n isn't a number, it still has a reciprocal. It's 1 over n. And then negative 5 becomes positive 5. So that turns into 1 over n to the 5th power. Let me write that a little more neatly. 1 over n to the 5th. The exponent stays with the number in the base. When we're working it out, do whatever. But when the final answer comes, it's got to be like that. Okay. Example C. We're just multiplying things together. So I'm going to have P to the 4 times negative 7, right? Well, 4 times negative 7 is negative 28. Again, I change it to the reciprocal. I put 1 over p to the 28th power. So I'm just showing with these examples, the whole idea behind these 3 examples is if the exponent ends up being negative, you can't leave the answer like that. You do have to make it into another type. So that's it for this example for part 2, and it opens up a lot more doorways. Have a good night.